Hello, welcome to today's seminar. This is Fiona Pratt with Applied Software, and I've got Michael Zeveld, who's going to be giving the presentation with us. The webinar is brought to you by Live Lab Learning, which is a subsidiary of Academic Corporation, a wholly owned company by Applied Software, to provide world-class training. We have many people on the meeting today. Sometimes we have people from all over the U.S. and even other parts of the world. So thank you for joining us. Throughout our presentation, we encourage you to interact. You will see the button that you can push to ask a question. Typically, we ask the questions at the end of the presentation, but if we see some that are pertinent, I might interrupt Michael and throw a question out there. So we're here to share information, and we'd like to engage you. That's why we're doing this as a live webinar and not a recording. We will record the seminar, and you will be able to view it on Applied Software's channel on YouTube, and we will send links to those who've registered. Michael's put up the screen listing our names. Michael, I think we've got some upcoming events coming up. Do you have a screen of those?
I do. Let me switch to that for us.
Okay. Can you go back one slide, please?
Sure.
This is a slide on the Live Lab Learning from Applied Software. For those who are not familiar with it, you can go to livelablearning.com, and you can pull up the classes from AutoCAD, AutoCAD LT, you see 3ds Max, Inventor, Revit. Sometimes we have some really specialized ones. There's also ones for the construction industry, the civil industry, manufacturing, fabrication. So we encourage you to look at this. Our classes are provided as live webinars led by an instructor, and lots of information on the classes and registration. So take us to the next slide, Michael, with the upcoming events. Okay, we've got 2 more webinars in the month of January. January 22nd, the benefits of Autodesk maintenance subscription. Many people know they have subscription, but they're not sure how to use it, how to access it, the difference between a contract manager and a software coordinator. So please join us at that time. On January 27th, A360 Team webinar. Just some buzzwords are Autodesk A360, A360 Team, and A360 Collaboration for Revit. So that's all to do with Revit. And then in Dallas, Texas, we're having an event focused on the construction industry. So that can include architects, contractors, subcontractors, field workflows, revolutionizing. We're showing ways the 3D intelligent models are being used to just change the way contractors and people are working in the field. Michael, what's your next slide? Guess we're ready to begin. Before Michael gets going, for those who haven't met Michael before, Michael's background is in architecture. He's got more than 16 years experience in the industry, everything from design and drafting to project management, serving the role as a project architect, working with contractors and owners, and he's been in the technology industry for many years, helping all levels of design and construction professionals become proficient with the latest technology. Michael is also really into the 3D visualization and, as you'll see in this presentation, the scanning. So I'll turn it over to you, Michael.
Well, great, Fiona. I appreciate that, and I'm glad that everybody is taking time out of their lunch break to join with us and share with this point cloud scanning little webinar for you. So I want to just welcome you here and appreciate your time. Glad that you're able to spend that time for you. I'm just kind of watching, making sure our screens are projecting and updating so I'm not talking about the wrong thing. The purpose of this webinar is Fiona sort of mentioned, is to talk about the scanning on projects, how we can bring that data in, point clouds and some of those other things, and those might be odd topics right now, but we're going to get into kind of describing that. And some of the elements we're going to talk about is using Revit, but specifically some of these scanning devices. One of it's called Dot Product, and then some processing software that we use to actually get it into and workflow it basically into our Revit particular software. There's many different sort of workflows in here, so we'll make sure we're sort of in tune and staying on track with that. We're basically just going to spend an hour. We've gotten into that a little bit already, but we're going to spend an hour kind of going over, explaining what the scanning information is, getting into the presentation, and then sort of wrap things up. And we'll also do just a QA session as well, so you guys get an opportunity to ask some questions. And if you want to save those to the end or chat those questions as we go through it, that's fine as well. We just wanted to give you sort of the big picture, if you will. So from a workflow standpoint, we're gonna get into this Dot Products software, which is the scanning, the point cloud elements, then move it through this processing software, which is ClearEdge, and then into Revit architecture. Now there is an AutoCAD sort of workflow. We can discuss that and get into that as well, but really we'll focus on this this next component, sort of this workflow, this sort of rainbow workflow of flavors that we're going to kind of move through the scan data into this particular software, these handheld type scanners, moving it into the point cloud, and then into this Revit architecture. And in most cases, when we tell that to people, they're saying, well, what are you talking about? They're scratching their head. Hopefully this is not going to kill you, obviously, but people are scratching their head saying, how do we do this? What are all these components, you know? And some of y'all have maybe already gone down this path of scanning in point clouds and are familiar with it, but they're not sure how to use the data and what's involved. So this is going to help hopefully for everybody. But let's sort of all start from the same standpoint, if you will, that what is a point cloud to begin with? People talk about this, and basically there's my little three-dimensional donut spinning around there. Hopefully it's spinning around okay. But you get the idea that there's all these little points of data kind of in the XYZ location that when a scanner or when objects project out, whether it's a laser or optical, they hit an object, they capture the XYZ location, and then reports it back to the scanning piece of equipment and really produces this digital image. A lot of people think of like, almost like radar or sonar when they're, finding a sunken ship or something. That's sort of the digital image that it projects back to us. And some of them are very detailed, some are color information, but really that's what this point cloud data is projecting to us. So when we look at this particular scanner that we're looking at, that's a handheld type scanner, and basically what that's encompassed is taking a Android-based tablet and combining with this optical device, and kind of like the sketch might imply, it's combining those two to make them very mobile, easily to move around. On the scanning side of things, there are a lot of other products out there. You might have seen some of the big tripod-mounted scanning equipment. It's very stationary. It looks like a surveyor crew equipment almost out there. And that's one way of scanning stuff. That's very much a line of sight. It's shooting out a laser. Just to give a sort of perspective of what else is out there from a standpoint of scanning equipment. But this one we've sort of focused in on because it is sort of unique. It's very mobile. It's putting into the hands of the users, of the people who would be out there scanning, basically the architect, as opposed to having to outsource this in this kind of black box kind of crazy scenario. So this is sort of the workflow we're focused on, and we can get into other questions down the road as far as what are some other scanners and that kind of stuff out there. But looking at this handheld scanner, here's just a screen grab of it to give you kind of a feel and look and idea. Obviously, if we were in the same room, I'd be able to show you this and pass it around. But it's a handheld device. See, there's a pistol grip, and that's mounted to this tablet, Android-based tablet, with some very specific software on it that is really the brains behind the whole operation. And on the front of it is an optical device. This particular one, this Dot product, uses the same optical device that the Xbox Kinect uses. So it's actually shooting out an optical image as opposed to a laser, just again another way of capturing the data. And from an accuracy standpoint, that's always important, is how dialed in are we? How accurate of information are we getting? Well, this is 2 millimeter accuracy at close range. What that means is basically 3 to 4 feet away. And basically, if you back out or have something further out at 12 to 13 feet away, that's a 4 millimeter accuracy. That balances out to be like a 0.01 inch or 0.08 inch or something. So very high tolerances, good for doing and capturing existing as-built conditions, historical renovations, just any existing sort of space. And we'll get into how this sort of collects the data as we go. And here's just some other statistics as far as accuracy and stuff. What I'm trying to convey here is that it's very accurate, it's very drilled in. The ranges I'm talking about is your handheld moving around. It's not stationary, putting up a tripod and having it scan some sort of room. You're actually moving around with this, going around the different furniture and different components, sort of thing. Now, some data or information about this, and then we'll move into the scanning part, is it's all on board this Android device. You're scanning, it's capturing this stuff. You see there's data storage, 16 gigs. There's also external flash drive type of stuff. And we can, transfer that information using USB or even into emailing, that kind of stuff. So just giving you some concepts of how the data is being stored, how can we get it, how can we access it, but then also, the size of this. If you picture a tablet and scanner and the pounds, it's a couple pounds, so it's easy to move around and not that difficult. I've had to carry one in my bag all over the all over the country, anyways. So just giving you context as far as what it is. Now, the unique thing about this particular scanning is this real-time color coding of data and capturing this information. This is much different than just a gray scale sort of capturing. When you start the scanning process, it actually starts to give you color indexing information. So it starts out as sort of a gray background. You start scanning and stuff starts to turn yellow, saying, hey, we're capturing this information. When it gets green, it's saying we really have an oversaturation of that data, sort of thing. And this is the same with any, I shouldn't say the same, but this is, you want to make sure you get good captured data with any scanner. I like this one because it's visually saying, hey, here's the, we're getting it. You're seeing it on the screen. A lot of times on other bigger scanners, you're not seeing it. You have to go back off site sort of thing. So this is visually giving you feedback immediately while you're out there. Not only is it capturing that data and information, giving us that yellow-green sort of information, it's actually capturing the photographic information as well. So, for example, this pump here is showing it on the left in the gray scale with the yellow and green, showing we got the good information. But then on the right, remember all that XYZ point cloud I talked about going out? Well, it hits every surface of that object and actually captures the X, Y, and Z location, but then also captures the photographic information. So it says this is sort of this reddish rust color, or the pipes are black, or whatever it may be, and then reports that back into the software, captures it. So a lot of people think of, oh, I'm just scanning, but I got to go back out and take photographs, or I got to go back out and measure everything. The difference with this is we're capturing all of that data at once, basically. So here's an image from the scan of this actual pump in this pump house or whatever, and so we're getting not only the three-dimensional model of all this information, we're getting the photometric data as well, and then which in turn this is all captured one-to-one, so we're actually able to measure and get distances and sizes off this stuff all at the same time. I mean, I can remember being in college having to go out with a tape measure and measure all this stuff and then take a couple pictures and get back to the office, start drawing it and realizing, oh my gosh, I forgot half the stuff. So this is really capturing it and grabbing it all for us. Here's just another space that's been scanned. You can see the uniqueness of it. It's capturing some carving on the wall, some stone, even different information and different textures and variances, just to give you that realism and level of quality. Now this is a good as-built condition. A lot of people will scan this and then be able to go back to the office. They're not having to recapture something or go back out and visit because they missed something. Another great example of this is, a little VW bug, right? Well, underneath you can see that sort of gray area where the license plate is. Well, in traditional scanning, that data would be missed because the stationary scanners are line of sight. If you can't see around the corner or underneath something, it's going to miss it. Well, with this handheld scanner, we'd be able to go down underneath the bumper and around and twist our arm upside down, and it will build and continue to sort of record and add the data to the model, so we can continually build and expand upon this. Again, here's just a small image example. I was actually scanning some of these black leather chairs in our office, and you might say, "Oh, big deal! It's just a leather chair." Well, it's more important because a lot of times, if you've gotten into scanning, black surfaces and metallic, shiny, chrome type surface are very hard to capture. And then in this scenario, I'm actually capturing both of those. The picture might be cut off a little bit, but it did quite well capturing that data and giving me visual feedback. So just to give you, another picture here, here's the tablet. It's an HP-based tablet. There's pretty much any kind of different tablets that you can use that are Android-based, loading the software on there. And here's sort of the flip back side. Here you can see the optics device on the top, and then the middle is actually where the pistol grip component goes. And you see there's some cabling on there, and I might have a slide later on that talks about if I wanted to extend this up on a pole into the ceiling to look around, do some scanning, I'd have the tablet down with me, and the optics would be extended up into the ceiling area to kind of get that additional line of sight. Or maybe it's even some higher up type crown molding or something I can't get that 12 to 13 feet distance away. I can actually extend that up a pole to get access to it. Again, here's just another slide. Here's a better picture of scanning that chair and data information, just to give you some context. And then here's actually I spoke too soon. Here's actually that pole condition where the tablet and the scanning device is at your fingertips, if you will, and then up a extended cable is the optics, and you can turn and spin and do the scanning in there. So hopefully that's given us some context of the point clouds, what the scanning is. Let's look at how this data truly is being captured. And for this particular scanner, they have this proprietary software called this Pi 3D, and basically it's launched on the tablet itself, and it goes through a little bit of a calibration. Because if you remember, I said this was optics, so it's kind of doing the Wall-E, sort of zeroing in, dialing in its eyes or something to get the right calibration and information. Once it's on, once it's warmed up, ready to go, we can hit basically the start button there in the upper right corner, and it starts to capture that information. Even if it's gray, black and white information, it's still capturing it. But eventually, when we start to kind of wash the scene, if you will, and they almost kind of give this washing motion, and I relate it to like a bad spray paint job where we're overspraying and capturing information. But again, you're moving around. We're able to go left to right and up and down, and it's tracking where you started. So it knows this overhead door spool corner condition. It recognizes that, so as we move away, it remembers and knows where that data and information is, and it will be tracking from that location. But if for some reason you slip, you trip, you jump, or somebody asks you what time it is, and you move the scanner really fast away from it, it will actually give you a message, say, hey, I lost the tracking, I lost where we were, but it's very forgiving that we can go back to a known point, and it will pick up that location, and we can continue scanning. Sometimes it will flash like an orange screen to say, hey, we lost the tracking, but it's very forgiving to come back and do that. And the reason, again, we sort of highlighted and grabbed onto this particular type of scanning is because it's very user-friendly, it's very easy, very forgiving, and price point-wise, very inexpensive comparative to some of these other stationary scanners, which if you own in them can get into later on cost. So here's an example of the captured area. It looks a little granular right now, but remember, everything is a point cloud that's being collected up, and we can actually do some slider here to adjust the pixelation of it, and there's also some other tools to do some additional cleanup. Now, one thing, before I would want to leave a site, on-site scanning job like this, is to make sure I have everything. So this has given us the opportunity to look at this data, to spin around, what did I miss, or if it is something I miss, is it furniture or something I don't care about. But it gives me the ability to append this data. And you can see this sort of slide deck of images here that says here are some areas that were scanned. The ones in red, we're sort of missing some data. We need to add or include some other stuff if you feel necessary. And it could be could be just some stuff on the floor or on the counter or something we don't care about. But it's giving us this visual before we leave, because sometimes you're traveling in the same city down to a project to scan something, or it could be across the country. You could be flying there. It could be a one-time scan access only. I know there's a lot of historical projects out there. There's a lot of museum-type projects where you only get access to scan this stuff once because they're shutting down everything. So something to consider before leaving. We want to make sure we have everything. So this tool in here gives us the ability to basically append the scanned areas. So we can basically click on that one of these boxes, say yes, I'd like to fix that or add some data. We say append, and it basically gets you back into scanning mode to rescan that area, add it to that data, and it's stitching it together because it knows some of the information in there, but it's this object recognition component that is saying, hey, yes, I know this corner, I know this edge of this counter or something, and we're able to basically recapture that information. So just going back and just rescanning it. Now for some folks, they're really into, they come from a civil background, or the civil surveyor type folks are moving into this space as well. And there's data markers, and this is just an example of a data marker that can be used. I want to point out that it's definitely optional. It's not necessary, but it's a target point to really hit up on some registration points. A lot of people will do this if it's a big blank flat wall, not a lot of variation in it. Sometimes the scanner's like, whoa, well, there's nothing really here that's different from one end to the other. So these calibration registration points help to kind of track that. And also in even like situations like this is it was a car accident, they're putting these targets on there to reference it, to make sure that this side is the correct side we're tracking, that kind of stuff. And also getting into just showing you sort of different slide decks of where things are located and how we're scanning it. This is provided, so you just print these out, paste them on the wall for you to scan. Not necessary, but it is an option for you. Now, this is the same area we scanned with that loading dock area, kind of in this warehouse. And I mentioned it was very pixelated, which is true, but even before we leave, again, this scanning job, is this optimization, or this global optimization. What that's going to do is kind of clean up and stitch things together and tell us, hey, that corner of that wall by the loading dock, overhead door, you scan that a lot, and we have a lot of points that are overlapping that we don't really need, making our file kind of heavy. So we can basically strip some of those extra points out, go through this global optimization. This is really one of the few, if any, products that I know that has this feature. And this is just to clean it up, give it a better quality, reduce the file size, get rid of some extraneous data, if you will. And then just cleaning it up where you can see that concrete wall, I can actually start to see some of the definitions of the block itself, and it's just cleaning it up, reducing the file size for us. Now, when we're done with that, we're ready to go, we can do a couple different things. We can actually take this file and save it to just an SD card that's on board the tablet, or just save it to the memory of the tablet itself. This is Wi-Fi enabled, so I can actually take these scans and email them out to folks or somebody back at the office. We actually have folks who have a scanner team, and then some folks at the office who are waiting to receive that. So as soon as they start sending data, they're already starting to work in it to bring it into more of a production mode. And a question may come up like, well, how big are these files? How do we know it can even be emailed or something? Well, the way the scanner works is it lets you scan an area and has kind of like a meter bar that says, oh, we're sort of full, or what we want to keep this file size limit to, and it'll ask you to stop and to save, which just takes a second to hit save. And then we restart scanning with a little bit of overlap and then continue on. So maybe in a room, four-sided room or something, you might have 4, 6, 8 potential scans, but it's to keep those file sizes small, allows them to process them very easily, or if you need to go back, that's how it's able to quickly come back and reference that stuff. So as I said about saving the images out anyways, we can give it a unique name, and we can also save it out to a lot of different file formats. And these file formats may not mean a lot to you right now. You see in that upper right kind of screen grab, PTX, PTS, XYZ, RGB kind of stuff, and then DP. Those are the PTX and the PTS are sort of standard across the board scanner file types. So if you said, hey, we already have a big scanner, but maybe we can augment this to use in some areas, there's like a pipe condition, we can't get it with the big scanner. This PTS and PTX can be incorporated into that bigger scanner's scans and all kind of play together in the same sandbox, right? So those are common file formats and nothing, that another scanner or viewing software couldn't read. The DP are just dot products specific applications they use, so really it's a choice which one you want to use. And also as far as measuring in increments sort of thing, is it meters, centimeters, inches, that kind of stuff, we can basically choose how we want it to be processed. And then we save it. Save it, do whatever we need to with it. And like I mentioned before, we can do USB cable, we can email it, we can do it to the thumb drive or whatever, save it out, and you're sort of good to go. And once all that data is captured, we're ready, and you can leave the files on there. We can clean them out, we can get rid of them, whatever we need to do. But we know before sending and before leaving, we've captured everything we need to capture, and everything's ready to go. Partially the reason that some of this stuff is pointed out on this slide, the arrows, the red arrows there, is the versioning. They're continuing to build different application, or version 2.0, 3.0, that kind of stuff, to incorporate different workflows. They recently put out a Autodesk Recap integration where these files can go right into Recap, which some of you may be familiar with. Another scanning sort of viewing software, not capturing it, but actually using it to view and that kind of stuff. So just a reference point there for us. And I kind of talked about this before, but that product itself, as a package, comes with the scanner, the tablet, the optics, the handheld, the case, all this different stuff. If you're wondering, like, is this a piecemeal that I got to put it together? It comes with all that stuff, sort of fancy, all combined and put together. So that's how we scan it. That's how you capture it, whether it's that particular device or maybe another scanning device. But the next thing is, I have the data. Now what do I do with it, right? And this has been a hang-up for a lot of people. And this is where we kind of keyed into this clear edgewise software, because people would scan stuff and will ask, well, I take it directly into AutoCAD, or I take it directly into Revit, and it's this big mass, it's this big blob. What do I do with it, right? I can't. It's sort of hard to process. And that is a direct route, right? But we can use this clear edgewise software to basically process the information and to clean it up for us. So ClearEdge is a company. Edgewise is a specific software. There's some slides, or the website there you can look at. But basically, their whole mission, their whole purpose for existing is to reduce time, to reduce man hours of taking point cloud files and then moving it downstream into a design application. So like we captured the information, we're going to process it through this software and then send it down to Revit. We can spend a very short amount of time in this software, or we can spend a little bit more time doing some processing. It's really what's more comfortable for people. So you talk about this reducing modeling man hours 75%, and completing better, the models than with 0 man hours, those kind of things. It's all about saving time. And it sort of comes in a couple different flavors, and really depends on your type of business and industry you work in. You can see there's for plant and MEP, and building and structure, really kind of focuses in on what type of work you might do. But then they took it a step further to say, well, you know what? A lot of people who work on buildings also work on the structure side of it and get sort of in the MEP of it. So they made them into suites. So there's a BIM suite, and then there's a plant suite as well. So just giving you sort of this option, if you will, to how this data gets processed. Well, we're going to kind of gear in or focus more on the architecture side of things, and we'd be more than happy to talk about MEP and structure and all other stuff, in another sort of webinar. But here we're kind of focusing on the architecture side of things, basically taking this data and processing it. So now, once we have that point cloud data scanned, we can launch into this particular software and take all those point cloud files. Remember I said you'd have a whole bunch of them. Well, this sort of listing out in here, you can see kind of PTX listed in here. This is just a series of parts of walls that they all scan, and we're going to build this up to basically create what they call this database. This is a one-time thing. It's to pull it all together. We're going to process it. And you can see there's a couple different choices that we can look at in here. I want to create this database, which we know, but it's asking us some questions like, is there a lot of ground plane surfaces or exterior? Do we want to include that? Are there a lot of mechanical pipes and ductwork and different things? Do we want to include that? Or are there a lot of planes, meaning a lot of flat walls, flat surfaces, soffits, ceilings, that kind of stuff, and that's what it'll key in on. If you don't have those other elements in there, it's really not worth it because the software is just looking deeper for those different elements. And again, this is a one-time sort of thing. It takes all those individual PTX files, basically combines them into this ClearEdge database. And you can see it talks about step 26 of 67. So this is, go get a cup of coffee, go to lunch, run it overnight sort of thing, because you don't want to sit there and watch that. And it could take minutes, it could take an hour. It depends on how many scans, your project size, all that kind of stuff. But at the end, you want to see, woo, all files have been processed. We're good to go. We can start to now look at all this stuff basically stitched together. Okay? And in the software, we can say, hey, here's that database. I'd like to open it up. Let's open up the model here to take a look at it and what's inside. And I know these may be some granular sort of steps. I'm not trying to get into those stuff, but I want it to have an understanding of what's involved, from your standpoint, because this is one of the only pieces of software I know that does this sort of processing and converts it. And when we get into the Revit side and we move downstream, you'll see like, wow, that saved us so much time and didn't bring a lot of extraneous stuff we didn't need. So once we're in we open up the database, we're ready to go. It's showing us this model information. We can start to view and look at this, and just trying to point out some tools for navigation, that kind of stuff, just to spin and move around. But here's an example of those scans of this particular project, which was this officers club, and these are all scans of the interior, but we're on the outside looking in, but there's kind of like you're seeing the mirror side of the inside of the outside or something. So these are the scanned walls. We're seeing all sort of the inside out. These are the scans. These are the point cloud files. Now, ClearEdge, the Edgewise software, is already thinking about these. Remember how we said there's a lot of planes in this particular model, just any kind of wall surface, as-built condition or something would have a lot of straight walls and floor surfaces. So this is the strength of this software of ClearEdge, is to process and start thinking about that. So it sees all these point clouds, along a wall surface, for example, and says, hey, I think this is a flat surface. It has a definite start and an end and a height, and everything's flat. I'm gonna start extrapolating that and give it some surfaces right off the bat. So if I go in and turn off up here in a sort of small up here in the upper left corner to turn off some of the point cloud information, when I do that, it then shows me sort of the shell or the extrapolation of what it sees as flat surfaces that represent these planes or these vertical wall surfaces. So, and this is a matter of like, a minute. I brought it in, I turned this off, there it is, I'm seeing it. And you can see some of these might have some missing data. There's some gaps. That's partially to the scan. Could be that some of the scans were missing or erased or something. But it's basically showing me this, what it interpolates as these wall surfaces. Okay, and we haven't really even told it to really chew or process anything yet. The next thing with this software is just what I call building this sandwich. So it's already identified these vertical surfaces. The next thing is to really find these flat surfaces, the horizontal surfaces, which would represent the floor, the ceiling, a soffit, a roof condition, or something. So we're basically telling it, we're coming in here, we're saying basically pick a level right here, and I'm just spinning it upside down, picking the floor, and you can see this particular scan it has some holes in the floor, which is fine. Could be furniture, pool table, whatever it is. The folks, when this was scanned, decided we don't care about that information because we're going to just put in a complete floor. So we're not going to waste extraneous time scanning chairs and furniture and pool tables, that kind of stuff. But basically what we're doing is building these planes. This is my floor surface. There's another portion of the building, the floor is up a little bit. So I'm building these sort of levels as I go. Here's just another perspective, clicking on different things, saying this is the floor, this is another level. Here, moving to a different angle, you can see this sort of series of surfaces in here. So soffit, roof, ceiling, whatever it may be. And I'm basically building this kind of scanned virtual 3D model sandwich. So I know I have these vertical surfaces, and then I have these horizontal planes. And the Cleared software is using that data to read and extrapolate. So it's saying here you have a flat surface plane on the bottom, and I have some vertical plane information touching it, and that goes up to a certain height to another sandwich level, if you will. We're going to interpolate that and say from that plane on the bottom to that plane on the top, my vertical wall surface, we think that's a wall. We'd like to convert that to a solid surface for you. Okay? And that's really the next step. And then by turning off those levels temporarily, just a click of the button over here to say uncheck levels, I can see this extrapolated wall surface condition from going from the bottom of my plane I picked, the top of the plane I picked, the vertical surface, and it sort of infills to say, we think, that was from one end to the other. We're just kind of rectangulating this information and filling in it as a solid object, solid surface right now. And again, that's within minutes of going through this process. Just another angle of it, it's seeing that stuff. But it's smart enough to say, here was a surface, here was an object. We only scanned the interior, so on the outside it says there's nothing for me to reference. I'm going to take that wall, turn it into a solid surface, and give it a default 5-inch thickness. Okay, so that's sort of what it did on these edge perimeter walls. But see some of these walls that have a thickness or a larger thickness to it, it was reading comparison of one scan on a wall in another room to a scan on a wall and saying, well, those two are back to back. There's nothing but a void in between there. We're going to kind of make a wall that merge those two together for us. Now, no scan is perfect. There might be missing data. Some things don't, connect. There's always adjustments you can make. And this is where I was saying we can make these adjustments here in ClearEdge or downstream in Revit, probably whatever is more comfortable for you, in my opinion. But just to show you, there are some tools in here to say, hey, grab the edge of that wall, let me pull it over, or let me adjust the thickness of this wall, or maybe it's stopping short because there was something that didn't get scanned in that other area. And here's just sort of a different angle, and it's giving you the positive, negative side. So the green side is the internal side, the side it was scanned from. We can adjust thicknesses, those kind of things, and change things up to whatever makes sense for our needs. Now if I quickly just click of the button over here, turn back on the actual scan data information, the point clouds themselves, you'll see that I can now see, that's kind of redundant, see what I can see, the solid surface walls, but also then this point cloud file data. So I can get a comparison of what was scanned, what's real, what's against the information, just giving me a better understanding, and I can adjust these thicknesses. Now I said some scans, it might have missed this corner or something. You see it's kind of a void. It's missing this wall condition over here. Well, there's some tools in here that I can actually extract a wall and basically draw some information and say, let me draw a wall in that missing gap, and basically just fill it in, make it happen in there. Could be that I just wait to do that in Revit because I know I can do it really quickly, but here I can infill it as well. Or if you're not going to do it in AutoCAD, you might want to do it here as well. But it's basically asking, where's the floor plan? What level is the floor plan at? What level is the ceiling at? That kind of thing to basically, draw it accurately to where I can, have a nice completed full wall. And one thing to not be of concern about is see how these walls sort of just butt up the corners to each other? That's going to clean itself up nicely in Revit. Same with these corners here. It'll know how to do the cleanup radiuses of them. So we don't have to spend a lot of time really tweaking or messing with that. Okay, so here's my scan data with the point clouds turned on. Another feature in here is we can basically extrapolate our windows and opening conditions. And you can see I have the scans turned on there. We can see where the windows are. Maybe I can position myself a little bit better so I can see it. But I want to basically tell it, hey, let's take and detect these windows, all right? And I'm just going to basically pick this wall. It turns green. And tell it, find the openings. Basically, it's looking for the planar differences. It's saying the wall is flat, windows are usually pushed in, or something's pushed out. So it's going to actually detect that for us and start to process, start to think about this on how it interpolates that, and then ultimately identify and say, hey, we're looking for these window conditions. We found them in this outlined in red here. These are some windows we want to basically create for us, which is fantastic. Now, it also happened to take this door, which has an interesting transom window above it, so we could convert that to a window and deal with it later in Revit, or we can just remove it for now and say, hey, I'm just going to focus on these windows. There are additional components, like it's not going to convert furniture or unique ceiling conditions, or certain components that they're adding to this as you go. But if we look at it in the aspect of I have all this stuff scanned, I'm processing, I'm getting into Revit, as opposed to sitting there with a pen and paper measuring, the existing or the old workflow. This is a huge improvement from a time standpoint. All right, so now I have this data, and I have my openings. It's recognizing it. Let me just turn off that point cloud data just to take a look at what I have. I can see my wall conditions. I can see the window openings. Those all look really good. And now I'm sort of ready to take this out to Revit. So you can see this button here. This is a export to Revit button. We can also just do a regular export to the left of that, which would just be export to like a DWG sort of thing. But when we do this export to Revit, which I'm thinking a lot of you are using, it's going to create this basically clear edge Revit file for us temporarily. So it's basically just going to extract this out. It's going to list out saying, what do you want to include? All our objects, all our information. I guess if you didn't want certain things, you wouldn't have to take it. But it's actually going to extrapolate that out. It's going to start to process it. As it processes it, it's actually taking it out to Revit, and it's going to launch a session of Revit for us. Okay? So we're kind of done with the processing pretty much for right now. So shifting gears. We've processed it. This is just realistically is taking me longer to explain it than it is to physically do it, which is again this processing software is just to move us downstream. So if we move now into looking at Revit, launching your Revit application, and to refer back to what I said, Revit can read raw point cloud files. There's a lot of different file formats. The problem is, it sits here as an indexes. It takes the whole thing in for you. It actually creates it as RCP file. We don't want to have to do that. That's the advantage of using this processing software, this clear edge software, is allowing us to bypass that and basically say, hey, I'm going to open up this particular model that came out of clear edge, and it's going to open it and launch it. And it actually gives us, and I apologize, screen resolution, sizes and stuff is hard to see, but this is in Revit. There's actually a Edgewise tab in here, again, because we're launching it from Clear Edge, bringing it through Edgewise into this Revit thing. It's actually giving me a specific set of tools related to Edgewise to deal with this, kind of this first go-round, if you will, of my model that we created, that we exported. So it's actually going to launch that Revit Clear Edge file. It's telling us, hey, there's no pipes we brought in. There's no duct work. We brought in all these walls. There's 55 of them. Looks like we brought in a handful of windows. And basically, here's my model. I'm in Revit. It took all that data, processed it through the point cloud, made it solids, and is now putting it into Revit. Here is the beauty that I got to explain to this. It's different and unique than any other situation. It didn't bring the point cloud data with it. It extrapolated and converted it, brought it in as true Revit families. Okay, so if I clicked on a wall, it might have a clear edge or edgewise, abbreviation on the front of it, but it is a Revit wall. It just has a different name. So I can click on that, and if anything it wasn't sure of, it's just going to make it a 5-inch generic Revit family wall that you can swap out and do whatever you want to. Same with the windows. They're families. Okay, big difference. It's not just extracted surfaces. They are actually Revit components and families. Now I mentioned about this tab, this toolbar up here. We can start to use that to maybe compare, look at some stuff, because Revit likes to take things and make sure they're nice and square in Revit. Well, you know how sometimes walls in the real world are wavy. It's going to try to straighten those out a little bit, and we might want to just verify a couple things and say, this wall here, I want to selectively bring in the point clouds associated with that. So I can do that. It asks me, where those database files are. We bring them in, and you can see it's putting the point cloud information right over top of that wall. The yellow means it's a little bit in front. The green means it's dead on. The blue means it's pushed back. So this wall in real scan might have been off a little bit. So we can use this as a measurement tool to say, let me pull that back. Let me adjust that. Let me either bring the wall to the point cloud or the point cloud to the wall. Either one, we can basically control it and tell it that's my wall, select it. Let me face it, and you see it's all green now. We basically adjusted that because this is a Revit thing. It likes to keep things square. So once we're done any kind of tweaking or comparison, we don't have to worry about a bunch of point clouds that we select the whole building lights up. This is all true now Revit data and information. And once we do a save for the first time, just file save as, it will save it as a regular RVT. We'll lose this edgewise little toolbar here because they figured you're done processing and doing some different stuff. So we're really now back into our workflow, and we would continue on from where we need to be. So this is a very distinct workflow on how we would typically approach a project, but really looking at this from a drill down standpoint of how we can get from A to B with a little bit of ABC in there or something. But I really wanted to take this brief amount of time, my 45 minutes if you will, to really walk you through that process and to familiarize you with this. Some people are saying, well, I've heard of scanning and we don't know what to do with it. Or I brought it into Revit and we couldn't handle it. Or now to introduce this sort of intermediary process to really get into the workflow of the dot product, which is the scanner, the clear edge, which is the processing software, and obviously Revit is the workflow path we went. We can obviously get into an AutoCAD workflow, but really wanted to just share that with you all. And I want to just take the last 5-10 minutes that we have here to really turn it over to if there's any sort of questions out there. There might have been some questions that were coming in while we were going through this. So I'm going to open it up to Fiona, myself, and the group here. If they had any questions, you can chat those back to us. I know one question that typically comes up, just to open this up, is sort of what type of scanner or scanning is best to use. What type of tool should I match for the type of project I'm working in? So the big the big tripod-mounted scanners are usually used for larger volumetric type spaces. Okay, so let's think of a mall, a church, a airport hangar. Those big scanners have a larger reach. They're laser, and they can reach out a lot further. Comparative to these handheld scanners, which is more, I'm just going to say, rooms and office spaces and that kind of stuff, where we can reach up with the pole to get it to bigger, further distances. But you're talking kind of opposite ends of the spectrum when you talk about even cost type of thing. So that's sort of the big difference, and there's a price point which Fiona and some of the salespeople will be glad to answer you that. Looks like there's another question here. Camille asked the question: how long does it take to process the scans on average? Okay, that's a great question, and really it depends on the complexity of the space that you start out with. If it's a office space with sort of flat walls and not a lot going on, it's going to process much faster versus, let's say, a historical preservation project with trim and crown molding and all these fluted columns and all stuff, it's going to take a little bit longer to maybe process that. But the strength of this ClearEdge software is to quickly chew on and crunch on the information. That Officers Club, I think, took to process it, I think it was like between 10 to 20 minutes. And usually I'm not sitting there watching it to let it run through it, but you saw that was probably 60 different scans, several rooms, areas and stuff that ran through and processed that. It really just depends if you've cleaned up those scans ahead of time, and I know this may be a longer answer than what's necessary, but really it doesn't take that long because that is its true strength. Fiona, did we have any other questions?
Yeah, I've got one question. And so it's kind of like a role play question. I'm an architect, and I've got a building. It's a hospital. It's a wing of patient rooms, and I'm going to do renovation. So from what I saw of the handheld scanner, that looked like a good way for me to go through the hospital, start scanning the rooms. I'm curious about maybe scanning what's above the ceiling, popping up a ceiling tile, scanning on a room-by-room basis, maybe down the corridor. So in this scenario, I said as a hospital, it could also be a school. But can you just give me a feel? It looks like the technology you showed me, the equipment, the whole getting it into Revit looks pretty good. Can you just give me a feel of the workflow and how that would be? You also mentioned you were showing the architectural version of the software, but there's also an MEP one, so maybe that comes into play too. So
yeah, so I think for your scenario you described, basically the handheld scanner is an optical scanner, so putting it above the ceiling is fine, and that's what that pole's for. We really recommend a light source because it's not doing like a laser, which the light source doesn't matter. You really want to put a light or something up there with it so it can capture that information. And I've seen folks, pop a couple ceiling tiles, reference it, and go that route. And then really, it's still the collection of how I showed it, and then into the processing workflow I described. But you are right. There is an MEP in that suite. There's an MEP, a structure, and different thing. And the reason I was only telling it to do architecture in part was because the project we had, but the MEP starts to look for piping, spherical objects, and it reads those point cloud files and does like an extrusion extrapolation to say, here was a pipe, it's this diameter, and it goes down this plane and then turns a corner, and it'll actually extrude that as a pipe object and actually do the elbows as well. So it's very intuitive in that format. It's obviously going to pick up whatever you scanned. If you missed a backside or something, it may actually extrude and continue that down. Or if you didn't scan it all but know the pipe continues through the wall into the next room, you can actually grab that and extend it down as well. So hopefully that sort of answered the question. I pulled up the questions here. It looks like there's...
Yeah.
Okay, go ahead.
I was going to say that does answer the question. So that brings me, what type of training is required if I purchase this equipment and the software? So there's the scanner, there's the software. What's the training, the learning curve?
The learning curve is pretty shallow, if you will, as far as we do a 2-day training with the ClearEdge software, the processing software, and usually a day on the front end of doing the scanner itself. It's very intuitive, pretty easy to use. It's just really defining the workflow and how you're going to use it. So it's usually a 3-day with a little bit of support in there, sort of a bundle package, if you will, that we've kind of created for that, allowing people to get a good understanding of it. But we have had folks who come to us and say, I'm familiar with ClearEdge, and I just need the scanner training. So it can be broken up, but typically it's all bundled together because folks haven't come across it like that.
Okay. Well, Michael, I don't see any other questions. I'll give everybody another couple of seconds. We've pretty much come up to our hour mark. Nothing else has come in. Thank you for explaining it. Appreciate you showing the workflow to the Revit, giving us some ideas of how we can streamline it. And I hope everybody listening in today will contact us and visit livelablearning.com for some of our classes, and Applied Software can be reached at asti.com, and we look forward to working with you. Thank you for joining us, and see you at another webinar.
Thank you all very much.